Hi friends, good evening. This is Uma. I am currently working as senior chemistry lecturer in Sri Gurukul Vidyalayam College of Science, Kasibugga, Palasa Town, Srikakulam District and Andhra Pradesh State. Today I would like to start part 9 of structure of organic molecules, which is subtopic of GOC, General Organic Chemistry. Part 9 is a continuation for part 8. In part 8, what we discussed, sir? Trick to find hybridization of molecules or ions. Now, in part 9, we will discuss about some typical examples for hybridization of organic molecules. Shall I move? Good. Sorry. First one. Typical example. First typical examples. Trick. In carbon free radical, that is C dot. Odd electron species or single electron species generally we called as a carbon free radical. Trick is one valence electron of carbon is not considered for calculate hybridization. This is one trick. In carbon free radical, one valency electron of carbon is not considered for calculate hybridization. See examples. CH3, methyl carbon free radical. In methyl carbon free radical, carbon valency, central atom is carbon, valency 4, 1, 2, 3, 4. This electron is not considered. That means what? One valency electron is not considered to calculate hybridization. Now see, sir, 3 hydrogen atoms form 3 sigma bonds. Tell me, sir, hybridization formula, what, sir? Number of sigma bonds plus number of lone pair of electrons. How many sigma bonds are present? 3. Lone pairs 0. That is sp2 hybridization. So methyl carbon free radical undergoes das hybridization, sp2. Now we will see second example. CH3 CH2. Yes. Now this carbon undergoes hybridization. What? Carbon valency 4. This electron is not considered. That means one valence electron is not considered. Now carbon radical So, see sir, two hydrogen forms two sigma bonds. One bond formed by this group, that is methyl group. Anyhow, three sigma bonds are present. Hybridization is equal to 1, 2, 3. 3 sigma bonds, lone pair 0, that is 3, that is sp2. So generally carbon free radical undergoes sp2 hybridization. Please think if this carbon undergoes dash hybridization. Tell me sir. Around the carbon all single bonds are present. 3 hydrogen single bonds, this is also single bond, that's why this carbon atom undergoes sp3 hybridization. This is over. Now see example C. Third one C. CH2 double bond CH radical. Tell me sir, double bond. This carbon atom undergoes dash hybridization. Tell me. See, this carbon valency 4, that is 4 electron. This electron is not considered. That means this electron is not considered. Now see, one hydrogen atom forms one sigma bonds and this group, that is what sir, CH2 group. CH2 group forms multiple bond. CH2 group forms multiple bond. See, here, tell me sir, hybridization, one sigma bond in multiple bond, one sigma bond is present. So 1 plus 1 is equal to, that is sp hybridization. This carbon free radical undergoes sp hybridization. This is one typical example. What is the trick? In carbon free radical, one valence electron of carbon is not considered to calculate hybridization. This is over. Shall I move second typical examples? Second example. See sir. Trick. If lone pair or negative charge is conjugation with multiple bond, then lone pair or negative charge is not considered to calculate hybridization. This is important trick. Lone pair or negative charge. Negative charge you have to consider lone pair. See sir, one atom has one electron, already one electron is present, it gains one electron. This is negative charge. So negative charge means what? We have to think it. 2 electrons. That is negative charge means what sir? Lone pair. Just you have to consider. Clear? Suppose A lone pair or A minus. So minus charge nothing but you have to consider one lone pair. Clear? That's why lone pair or negative charge is conjugation with dash multiple bond. Conjugation with multiple bond. What is meant by conjugation? Conjugation means what? Conjugation means what? Please think it. Conjugation means what sir? Separated by single bond. Separated by single bond. That means what? That is, lone pair negative charge is separated by lone pair negative charge and multiple bond is separated by dash bond, single bond. That is conjugation. See example. CH2 double bond CHC CH2 minus. Are you ready? See sir, negative charge conjugation with multiple bond. Negative charge is conjugation with multiple bond. Conjugation means what? Separated by single bond. That means negative charge and multiple bond separated by single bond. That is, this molecule or this ion conjugation present. In this ion conjugation is present. How sir? Negative charge and multiple bond is separated by single bond. That means what? Conjugation. Negative charge and multiple bond separated by single bond. That means conjugation. So this molecule, this ion has conjugation. For example, CH3 CH2 CH2 minus. See sir, in this ion, negative ion, if conjugation present or not? No. Why? Negative charge, single bond. Here there is no multiple bond. Double bond or triple bond is not present. Here there is no conjugation. Conjugation means what sir? Separated by single bond. Which are sir? Lone pair or negative charge and multiple bonds are separated by single bond. Tell me sir, in this case, conjugation is present. Conjugation is present. Conjugation is present. That means what? At that time, negative charge lone pair is not considered for to calculate hybridization. I want this carbon atom undergoes which hybridization? Tell me sir. Carbon means valency 4. 1, 2, 3, 4. Clear. Minus means what? Excess 1 electron is there. Excess 1 electron is there. Clear. Tell me sir. Minus means what sir? Already 1 electron is there. Excess 1 electron is present. That is, you have to consider one lone pair. One lone pair. So this carbon has single bond, forms single bonds with 2 hydrogen atoms and single bond with this entire group. Clear? So negative charge or lone pair. Negative charge means what? One atom has 1 electron gain. If one atom has electron, it gains 1 other electron. That means what? It gets a negative charge. So negative charge means what sir? Electron pair, lone pair you have to consider sir. Here in this trick you have to consider lone pair and negative charge are equal. You have to remember that point. Trick only. Okay. See sir. Now hybridization, tell me sir about this carbanion. How many single bonds are present? Sigma bonds 3. Lone pairs 1. That is 4. sp3 hybridization. Clear sir? I made mistake. Sorry. Negative charge is conjugation with what sir? Multiple bond. That's way. Tell me sir, tell me. Negative charge is conjugation with multiple bond. That's why that negative charge or lone pair is not considered for to calculate hybridization. That means this negative charge nothing but lone pair of electrons are not considered for to calculate hybridization. Clear? Now tell me sir, hybridization is equal to number of sigma bonds, how many? 3 plus 0, lone pairs 0, 3. That is what sir? sp2 hybridization. this carbanion, this carbon negative charge carbon undergoes sp2 hybridization. What about this example? We have to think it. Here there is no conjugation, sir. Negative charge, single bond, there is no multiple bond. Conjugation is absent. Conjugation is absent. That's why this negative charge you have to consider. Here negative charge is not considered to calculate hybridization. See, sir, carbon 1, 2, 3, 4. Negative charge means what, sir? Excess one electron is present. So hydrogen, and tell me, sir, entire this is one group, sir. Forms sigma bond, this bond. So one lone pair is present. Tell me, sir, hybridization is equal to how many single bonds are? 1, 2, 3. 3 plus lone pairs 1, 4. That means hybridization what, sir? sp3. Please think it, sir. If this negative charge conjugation with multiple bond is its hybridization is equal to sp2. There is no conjugation. That means it undergoes as sp3 hybridization. Shall I move another example? Tell me, sir, second example. CH2 double bond CH NH2. Tell me, sir, what is hybridization of nitrogen atom in this molecule? What is hybridization of nitrogen atom in this molecule? We have to think it. See, this lone pair is conjugation with what, sir? Multiple bond. Clear? Lone pair is conjugation with multiple bond. That means lone pair and multiple bond separated by single bond. That's why, tell me, sir, this lone pair is not considered for to calculate hybridization. Tell me, sir, nitrogen atom valency 5. 1, 2, 3, 4, 5. 2 hydrogen atoms form 2 sigma bonds. Now see, one sigma bond, this is sigma bond, forms one group. This is considered as one group. How many lone pairs are present? 1. But this lone pair is not considered. This lone pair is not considered to calculate hybridization. Tell me, sir, hybridization is equal to number of sigma bonds. How many? 1, 2, 3. Lone pair 0. 3 plus 0, 3. That is sp2 hybridization. Tell me, sir, in this molecule, nitrogen atom undergoes dash hybridization. Tell me, think it. Here there is no conjugation. That means this lone pair consider to calculate hybridization. Clear? That means this nitrogen atom undergoes which hybridization? Nitrogen valency 5. Clear? So hydrogen, one bond form with what, sir? This bond. This bond form with the entire group. This is one group. So it has one lone pair. Tell me, sir, hybridization is equal to how many sigma bonds are present? 3 plus lone pairs 1, that is 4. That means what? It undergoes sp3 hybridization. If lone pair conjugation with multiple bond, then that lone pair is not considered to calculate hybridization. That's why it undergoes sp2 hybridization. 3 sigma bonds only. In case of lone pair not conjugation with multiple bond. Lone pair, single bond, there is no multiple bond, there is no conjugation. That means that lone pair we have to consider to calculate hybridization. That means 3 sigma bonds and 1 lone pair is present. So 3 plus 1, 4. Clear, sir? I will give one more example. Tell me, sir, last example. Tell me, sir, this lone pair consider or not to calculate hybridization? Good, not consider. Why, sir? This lone pair conjugation with, tell me, sir, double bond. So not consider. That means how many sigma bonds are present hybridization? Tell me, sir. 1 sigma, 1 sigma, 1 sigma. 3 sigma bond. There is no lone pairs. That is 3. That is what, sir? sp2 hybridization. Very clear for you? Now tell me, sir. This lone pair consider to calculate hybridization? Yes. This lone pair separated. There is no multiple bond. There is no multiple bond. Nothing. There is no multiple bond means what? There is no conjugation. That means this lone pair we have to consider to calculate hybridization. Tell me, sir, hybridization is equal to how many sigma bonds? 1, 2, 3. All single bonds are sigma bonds and one lone pair, that is 3 plus 1, 4, that is sp3 hybridization. Okay, with your permission I can stop here. What we discussed today? Two types of typical example, 2 types. First type is carbon free radical. If carbon free radical present, one valence share of electron not considered to calculate hybridization. Second typical example, if lone pair negative charge conjugation with multiple bond, then lone pair negative charge not considered to calculate hybridization. Some more typical examples are present. We will see next video, that is part 10. Bye bye. Thank you.